then this is my notes that essentially helped me with 4, 5, and 6. So pretty much, let me show you my problem set. So the definition for the null hypothesis is that there's no difference between blah, blah, blah. So what I did for number 4 is I predict that there's no difference in the average between minutes of CSULB students watching Netflix from 2010 to now. And you're gonna do this Greek letter equals 65, which is the minutes that now and the past are equal to, if that makes sense. So pretty much for the null, there's no difference. That's the main thing. So when you make your hypothesis, you can put, I believe that there's no difference. My hypothesis is that there's no difference. And she didn't really want it written like that. I did it just in case. But the main thing for the null hypothesis is that there's no difference compared to the one-tailed hypothesis, where here the main thing is, I wrote the keyword is that there's a greater or lesser comparison because it's a directional prediction. So pretty much here I predict that the minutes spent on Netflix is currently greater than 65 minutes per week from 2010, and I wrote it like that because the one-tailed hypothesis is when you can measure what's greater and what's not greater. And then it's the opposite for the two-tailed because, well, not really the opposite, but you can't say greater or lesser. You're just assuming that there's a difference between whatever you're measuring. So same thing, the keyword for that is that I did was the difference. And so my hypothesis was I predict that there will be a difference between 2010 and now. You don't necessarily have to do it like that. The main thing I think for these two is that for the one-tailed, you make sure to emphasize that there's that one of the measurements is greater. And then for number 6 is that there's a significant difference, not necessarily if it's greater or less. And then this, she gave us straight up the definition. I think for these two, she gave us straight up the definitions. So p-value is when you assume that HO, or the null hypothesis, is true, and it's the probability of observing a statistic test as or more extreme than what is observed. Yeah. And then for number 8, she said that it's usually set at 0.05, which is 5%. So I put the conventional level of significance is usually set at 0.05, and I just added the 5%. Finally, for number 9, when the null hypothesis is rejected, an alternative hypothesis is supported. And I wrote that this is true because it sounds weird, but pretty much if there's no difference, then that means there's a difference. That's pretty much what it's saying. Then lastly, for number 10, when an observed p-value is higher than a level of significance, the null hypothesis is rejected. I put false for that because when we did the problem, when we did like an example in class, the last step was to either reject it or not. So pretty much you reject the null when the p-value is less than 0.5. And in here it's saying you reject the null if the level is higher. So it's false because if the p-value is less, then you reject the null, if that makes sense. So yeah, hopefully this helps you in some type of way.